All right, recording has been started. Welcome everybody. No one signed up to host a topic tonight, so something that's been on my radar for a while, and it's very timely for KnightKrawler because we're going to start prototyping for mini trials tomorrow night. Is I'd like to chat about what teams are doing for prototyping, and specifically if you have any like rapid prototyping rigs or techniques or tips that you're doing. I'm particularly interested in what you built or what you're using to be able to get a rapid intake prototype or rapid shooter prototype put together quickly. But other than that, I think I'd love to start off the night tonight with just sort of an open topic. So if anybody has anything of interest, something they've stumbled upon, starting the new year, new challenge, new resource they found that they want to share, please, by all means, let's kick things off with just sort of an open format here. Does anyone have anything, any news or any questions?
I don't know. Okay, but like there was these like new like Swerve drives that were released, so I was wondering if anyone had any like thoughts about them.
I don't. Is this from West Coast or who's releasing it? Is
I think
it West Coast?
it was West Coast, and they had like bigger wheels, and they were like a lot wider. So I thought that would affect some stuff. Yeah.
Sam, you're nodding your head. Have you looked into this?
Yeah, we looked at them. We're talking about it. I don't know. It's a hard to know. Like, I think there's some advantages to them, but it's like we're kind of in that like, is it worth like swapping like modules for that last 3% or 5% of performance or that they might have? What's really cool is they're super configurable. So like, if you ever find yourself like designed in a corner because you have like those modules there, there's a lot of different options to get out of that corner, which is kind of cool.
Oh, I'm looking at the website now. Yeah, wow, very configurable in terms of motor placement. Interesting.
And the price point's really attractive too. I mean, if you're already in like the double Kraken, we're running the Rev, so like it's way cheaper. But if you're already in the double Kraken double Kraken per module, if you don't mind like that, it's cheaper than SDS for sure.
And
so
I
cool.
see one here where they've got, it looks like a Kraken and a 775.
Yeah, you can run that.
Or a 550. The tricky part, I think, here's the thing that hangs me up all the time in Swerve is I advocated hard for Rev this year, and I lost that debate because I heard that at Champs, people came around and they said, what kind of motors do you have in your Swerve? And if you weren't running Krakens, they were less interested in you. Now, that's presumption, is the presumption was they wanted to hear you say that you had Krakens on your drivetrain. For the elite teams that were looking to pick up teams for their division there. So anyway, SDS is faster, more powerful. I get it. But the problem is that we've done Swerve 3 years now, and every year we have some mysterious inverted something here, inverted something there, and we cannot get our drivetrain to run correctly in the right way using native WPI lib. And so the benefit of Rev was that you get a library and you just hook things up in the order they tell you to hook them up, and everything just works. And you're driving Swerve and autos in hours and not days or even weeks. And last year we said, okay, we got it figured out. We put together our MK4Is and we put them on the robot. And then we spent days trying to figure out why we were turning the wrong direction or why our odometry couldn't keep track of our position. And then somebody got it to work. And I said, what did you change? And like, we have no idea. Don't touch it. Commit the code. And I just can't. It's just so frustrating to me to be in that type of a situation where you don't understand how to set it up. And the worst part about that too is with the WPI lib is you search the internet for how to do a setup, and you find random posts on Chief Delphi, and you have no idea if this inverted flag set to true or set to false is really the right way. It's just what somebody said. And I find that really frustrating. So the benefit of the Rev modules and the SDS is if you run full CTR, everything, Pigeon, Krakens, everything, is you get the libraries and you get those support. Does anyone know about the West Coast products, if they've got a library for that, or if they've got better instructions on how to get it to work with WPI lib?
I think, are you guys running do you have experience with the CTRE like Swerve generator?
That's
what
what
you're
we're
using?
going to do this year. So we bought everything CTRE for this year's Swerve so that we can do that.
And see, like that's honestly our biggest reason for wanting to switch is using that, because it's got all that better odometry, and it's taking advantage of a lot of the software. CTRE is way ahead on the software of Rev basically, and so we don't know how much of a difference it is, but it does seem like kind of the consensus with the elite teams is that, and so, and, we've run the Rev, but
so presumably if you had all CTRE with the West Coast Swerve, it wouldn't matter whether you're doing SDS or West Coast. If you're running full CTRE motors, encoders, and gyro, then you'd be able to use their library.
Yeah,
I think it's an option on the Swerve generator. I don't have Phoenix X on my computer that I'm using right now, but if you have Phoenix Tuner X with that Swerve generator, I think you can select some WPC modules.
Okay.
Somebody can verify that if they have that available.
I need a logic table.
We've used it on our Swerve last year with that generator, the Phoenix one, and it was easy enough that I could do it on my prep, which is pretty astounding because I am not good at that. So,
see, for a team like us who just literally diving into this, we just dive into the world of robotics too. But now we just came in a world when Swerve began to explode thing everywhere. I think we've decided to go with Rev for now is because of the availability of parts. I've looked into WCP products, and it's just one of those things where it's like things are always back ordered and things are and then who has the time to wait 3 weeks into build season before you can possibly get something. Unless you have the expertise of kids that will put something together in a matter of 6 to 8 hours and then get it going. But so when you look at it the way when it comes to resource management, it's just make Rev a bit more palatable for newcomers teams who are trying to dive into it. And it really helped to have the library. Mm-hmm. We did not have. The only coding problem we had was when our RoboRio got corrupted, but that's not a Rev library thing. It's a Rio 2 problem. But once that got figured out, and it worked really seamlessly with with the other libraries like the other sensor libraries that you can vendor libraries that you upload in your code. We didn't really have much of a conflict with any of that, and we don't have a strong programming team, so our programming mostly is outsourced, and so being able to actually run a whole competition with the person who will help us with our code not being there, that really just show for the feasibility of running a Rev if you are just coming into it, if you don't have a good footing in it, if you don't have a strong programming base. That would be my push for it. Question regarding the Rev. The other thing too was they brought out the new Vortex motors last year, and I need to talk to Ryan. He's kind of been busy being a dad and all that fun stuff, so I need to find time to talk to Ryan. But his team was one that really tried those Vortex motors. And I know there were a couple of times where he's mentioned about having more than, I think, 2 or 3 motors, and then suddenly you have a conflict in your code how they were communicating with each other. And so, but I think they worked that bug out. And so I was kind of, the reason why I'm talking about this, I was thinking about maybe just switching our Neo to those vortexes for the put out of the drive motors. One, just because I personally am despising the Neos because of that. So stupid wires that can break so easily. Even with the adult, when I handle them, they break. And I'm talking about kids who think everything is primordial and it should be like caveman like. So having this flex control motor, integrated motor controller with that, I feel like that's I think it's like $4 or $6 more actually, because Spark Max is about $96, and that integrated motor controller is about $100, and the price differential would be in the Vortex cost versus a Neo. A Neo is about $48 from Rev directly, but still, when you look at it, if I don't have to replace the whole motor because I don't have a repair kit for the Neo because that wire breaks, then the whole motor becomes quite useless for running a brushless motor system. So, I mean, there's give and take for the rev stuff, but I think the good things about it for newcomers and team with low resource and low budget,
Yeah,
in terms of
the price point of Rev is the best. I mean, that's actually one of the reasons we went with it. It's just because we said if we did it, we almost wanted 2 drivetrains pretty much just to be able to like play with code on one while developing, and it was way more attractive to do that. Yeah, I'd recommend the Flex too, or like the Vortex with the Flex. We did that last year, worked great. A lot more torque. You don't have to mess with that extra Spark Max controller. Like you said, the encoder wire was awful. Just breaks. I don't know.
And the other thing about that, my kids, we called it a cute bot because I have these 2 new builder kits, and I told them to take about the modules, put it back together, put together a 18 by 18 drive chassis, so they can then the other 2 new wiring kits to learn how to wire. And doing that, they ran into this thing where I think, and I told them, like, how can we fix this? And maybe that's something other teams have figured out. Their bore through encoder that goes on that module, they have a switch, that chooses which channel, and the fact is sometimes Ref has sent us those things and they have been non-responsive, like the factory malfunction. But it's a pain in the butt after you assemble the module before you find out that doesn't work. So I told the kid on Saturday, on Friday, I said, hey, maybe take a motor in a Spark Max, take one of those board encoder, take the adapter, make a kit. Before you ever put any of these in a module, test it through the ref in a product in a tool, and make sure that you can actually see that the encoder is working before you assemble everything together and not have to take it back, take it apart, just so you can switch out that one part. I mean, it's no big deal when you're home, but it's a big deal when you're at competition and suddenly, yeah.
Lily, since you asked the question, what are you guys thinking Swerve wise?
I was originally gonna ask our team for MK4Is because we currently have MK4s, but after seeing the new releases, I'm not quite sure what to do because the wider wheels give more, what is it called? More traction, and I know it's better to have more traction, but I don't know how much better that would be. And I'm also trying to move my team towards Krakens because we're currently using Neos right now, I think.
Yeah, I will say that I've always been pretty vocal about this, and I've always been pretty frustrated about this. Is that if you have to use WPI lib sort of raw and you don't have any other helper libraries or helpful tools to make sure that you've got it set up properly, the WPI Lib documentation isn't very good. The sample code has no autonomouses where the robot actually rotates. And so that was the mistake we made the very first year we did autos, is we ran all the WPI Lib samples for Swerve and everything worked. And then we started to write a real auto where we rotate the robot as it drove, and it had no idea where we were. And had we discovered that over the summer when we did our sort of trial run of Swerve, nobody thought about it. We like, oh, we ran all the samples. It does what it's supposed to do. We figured out Swerve. And then we spent weeks trying to figure out why odometry and our Swerve modules weren't working together properly. And so I like what you're saying about moving to Krakens. I think that's smart. If you're going to do Neos, I think you should do do the Rev Swerve modules. I don't know. Maybe I'm just gun shy because we've had so many problems. I know other teams haven't had nearly the problems that we have had getting their Swerve code to work. I think we're sort of cursed that way. But I am looking forward to being able to use the vendor library. I think that I don't want to be spending my time fighting bugs in Swerve. I want to be spending my time helping students write cool autos and cool mechanism code rather than tracking down weird configuration issues.
I have a question about, have many teams converted to Krakens by now? And reason being is, this is on the Talon team, they're thinking of putting everything as a Kraken, make it. But from what I'm hearing is they might be more of a power drain. So I'm wondering if anybody's had experience. I know when we were at the last tournament, one of the teams said they went to Krakens, but they had about 20 seconds extra battery life, more than if they're 2.5 minutes, if they had 20 more seconds, they would have been dead. So that's a curiosity I have on the Krakens.
We are running Krakens on our Swerve. We've already got them. They were delivered last week or the week before. So we have our Krakens for our Swerve. We'll probably still run, if there's a shooter, I suspect we'll probably put Krakens on the shooter for the power. We'll probably run Vortex on intakes because they're really nice to be able to put in line with the shaft. If an intake works similar to how the intakes have worked the last few years, we'll probably put a Vortex on there just for spacing. We'll probably use Neos on indexers and things like that because we've got them and they're not that big, and usually you can get a motor controller pretty close to an indexer. So I'm sure we'll run a mix of whatever we have on hand, but we'll be running Krakens on our Swerve chassis, and if there's a shooter, I'm sure we'll have it on the shooter as well.
Well, as I said, I'm interested in power consumption more than anything.
Well, so I was gonna say the big thing, Eric, is that I believe the Krakens are actually the most efficient motor out there too, by the motor testing. So it's really more about putting in like sane current limits and using like sane voltages when you're running, so you don't brown out. Those teams maybe do run out of battery, but it's also because basically the new thing about the Krakens is they will use as much power as you give them. So if you give them your whole battery, they will eat it. And so it's really more about, configuring your software so that they don't do that. It's kind of been our understanding, at least. We're looking to switch over to them just because, honestly, the software is so much better and the Falcons are gone. So, yeah.
So, Eric,
that's a good point.
So, Eric, are they using, the other thing too, are they using old batteries or newer batteries? Because when a battery life, I don't even know what is the longevity on these 12-volt batteries that we use, because I told my team captains, like, we're going to buy a new set of batteries just for competition this season, and those batteries need to be labeled like when it was, when we purchased them, and because I don't want us using batteries that we have from previous seasons. You charge them and you think they're good to go, and then you get there and then they drain out fast, and I was like, holy cow, I thought I had 12 ones, 5 reading on this thing, but it's before you know it, start giving 11 volts. Yeah, we've had that, and we've lost some good matches that we could have won due to electrical problem like that. And so I wonder if the batteries are using also have to do with some of that too.
Well, I think that you're not going to be changing your motors during the season as your batteries degrade. So you have to look at worst case scenario through your season and then through postseason matches. You want your robot to still be able to perform a whole match.
I was just going to say that we did some battery testing this last year, and we found that brand new batteries did not perform as well as batteries that have been charged many, many times. We actually, over the season, we saw performance get better. I'm not exactly sure where the performance starts to degrade, but that's something to keep in mind if you're evaluating batteries. Is we have, I can't remember what tester it is, but I think it's the one you can buy off Andy Mark.
I know we test. The other interesting thing we learned is that you don't want to store your batteries in your trailer on a cold night, because first matches might not even work.
And you also don't want to store your battery drain too. You want your batteries always charged, when you store them.
I know we've in the middle of winter, we've turned up at tournaments and wonder why our batteries the robot's so sluggish. And well, we used to have grease in there too, in our gears, and they were cold as well. And the batteries were just too cold till they warmed up. And so anyway, that's something totally different, as I said. I think current limiting what you need is probably going to be the trick to using Krakens, from what I understand it.
Lily, I want to make sure we keep coming back to your question. Do you feel like you got some good answers, some good feedback with what you're thinking about, what you're considering with your Swerve?
Yeah, I think I did. Now I think I'm definitely gonna move towards Krakens, and I have some better arguments to push for more Krakens. But another thing that my team, I was probably gonna do for like motors and stuff, I was thinking of using both Krakens and like Neo. Wait, yeah, was it? I don't know. It's like Neo Vortexes or something, and we were gonna use them both on the Swerve drive, which I think is like a little complicated, but I feel like it might work. I don't know.
So if you do that, you will be forced to work with the WPLA directly, which is the thing that has frustrated our team multiple times. My recommendation is, if you've got the budget, run 4 Krakens. But the CTRE is only good if the entire system is CTRE. So you need to have the CTRE encoders, and you have to have Pigeon. You can't use, I don't know, do you know what you use for a gyro? Are you using a Navex or a Pigeon?
I think we're using a Pigeon.
Okay, then you'll be okay. KnightKrawler has used a Navex. This will be our first year using a Pigeon, because we had like 3 Navexes, so we just kept using it. But if you want to use the CTRE tools and library, then you need to be fully CTRE in all your drivetrain components. If I'm wrong about that, somebody point that out to me, but my understanding is you need to be fully CTRE to do that. Okay, Sans aggressively nodding yes, that is true. So I think the big thing, Lily, is that if you want to make your life easier, you need to be fully in a system. So fully in the Rev system or fully in the CTRE system. The cool thing about the Swerve modules, if you haven't bought them yet, and the West Coast are in in stock. What I heard someone say is they're cheaper, right? Someone said the price point was attractive. Did I hear that correctly?
Yeah, yep, they are. Yeah, when you compare it to SDS, for sure.
Yeah.
Yep.
So, I mean, I don't know anything about the system, and obviously it's their first year, and there could be some growing pain issues with first releases. But if you haven't bought your modules yet, the price point alone is probably going to be the biggest factor of why to buy one or the other. Other than the fact it's sort of an unproven system, but I don't know if you haven't purchased anything yet and you're looking to buy. I think the West Coast sounds like something you should definitely explore.
It looks
But-
like they have 3 new modules out for West Coast, but I think their Swerve X, the original ones, were out for at least a year last year.
Oh, were they? Okay. Well, then
I think so.
then they've got some experience under their belt.
And they also are going to release another set of like their extra small modules this coming week, they said. And people are speculating because so basically RC, the owner of West Coast Products, said it's going to have future compatibility with like future smaller brushless motors. So read into that what you will, like if that's coming in the next couple weeks or years or what, but I don't know.
Yeah, it sure would be nice if we had. I mean, I'm looking at this extra small module with a 775 on there. It'd be really nice if we had a Neo 550 style in the CTRE family.
Mm-hmm. Well, because like a Kraken is total overkill for that turn motor. It works just fine, but it's just total.
It's so expensive for a turn motor. Yeah, I totally get it, and I agree.
Yeah, I was thinking of just like running 4 Krakens for like the drive motor, and then like Neos for the turn motor, but I don't know how it's gonna work that well.
You're gonna sign up for software pain, I think, is my if you're willing to, if you have like the chops for it, I think yes. Otherwise, it's probably easier to raise the money, honestly. Like it's pretty tough.
I'm looking at this with the 775. I mean, if you ran a Talon SRX motor controller, I mean, that's in the CTRE family. I wonder if you could run a 775 with a Talon SRX motor controller, because that's got an encoder wire. Oh no, that's the turn motor. So the encoder you don't even use the motor for the encoder. The encoder's on the turn shaft. So it's just driving the motor, but it's still in the CTRE family. So I wonder if the tooling makes that work. But Lily, yeah, that's the point, is you're mixing families. So when you mix families, then you don't get any help from the libraries or the tooling, and you got to do it all manually.
The other one you mentioned, Lily, was the wider swerve wheel as an advantage. And honestly, I don't know if there's consensus if that's like, in theory it's better, but also like sometimes with swerve wheels you're dragging the wheel a little bit, so it actually, like, when you're spinning and translating and like the wheels are responding, you're actually dragging a little bit, and so it's going to make your dragging worse. So I'm not actually sure if there's like a consensus on what's better. I think for raw acceleration, it's certainly better going in a straight line. I don't know. I'm not saying yes or no, but I'm saying that might be, assuming it's better, I think there's maybe more to it than that. But if someone knows more, that'd be, please speak up.
Looking at the Phoenix 6 documentation, it lists Talon FX, Camcoder, and Pigeon 2.0 as supported devices. So the Talon FX is really only the Falcon 500 and the Kraken.
That's interesting then that they've got this 775 on here. Huh. But I mean, again, you can still do it directly with WPI. It's just a little bit more effort and a lot more difficult to troubleshoot if you run into issues. But Lily, what you have suggested is possible. It can be done. It probably is just going to be a little bit harder. Or it might not be. You might get lucky. Well, you may not be unlucky. Maybe that was the better way to say that. Because I don't know that KnightKrawler was the normal experience. I think we just made some mistakes and then we paid for it in our code. Okay.
Oh,
Yeah.
sorry.
Go ahead. If you have more Swerve stuff, I was going to see if anyone else had anything else, but please continue.
Oh, for 3926 also had like issues with the Swerve using Rev libraries and like stuff as well.
Really interesting. You might be the first one I've heard say that.
Like the wheels were like funky or something. Like they weren't turning right. It was kind of strange.
Jeremiah, you guys ran Rev last year. Did you have any issues with turning or anything like that? No, you're muted.
Say that again. Sorry.
You guys ran Rev last year, right? The whole year.
Yep.
Did you have any troubles with your code with turning or wheel rotation or anything?
No. Matter of fact, I think because my kid was just starting to drive Swerve that same year, we actually toned it down to that we dampen it a lot. And so this year, hopefully we'll unleash the 550 and see what, because I think I talked to you, Scott, about probably changing up to a bigger motor side for the turn motor, but then, I don't know if it was you or someone, and I had that conversation. And
doesn't sound familiar.
The game may not be as beneficial for doing that, but just being able to, maximize what you have on a 550 will probably be a better serve. But we never ran into any issue regarding turn.
Okay.
The one thing I would say, Lily, if you go with Rev, is that you want to bring a lot of spare parts. Not a lot of team runs it. And so, the generosity of gracious professionalism in first that you see a competition may not work if they don't have the stuff there. So what we did last year, we bought 2 sets, and one was backup in case, and we had it already pre-assembled, and one started crapping out. Just pull it out and shove this one in and wire it back together, just like a NASCAR pit. So, and then this year, because we're still gonna go with that, what we decided to do was just got more up, the gear upgrade kits and all those. Make sure that all those gears get like 2, 3, back up to that. And so just because you're not going to be 100% sure that you'll be at an event where somebody else might be running Rev, and if there's somebody else, they may not have enough to go all the way around. So just that's something to keep in mind. What's up, buddy?
I would say our Rev modules have been really fragile. We could do a whole talk on like how to make them not break, but I think we've had a lot of issues, honestly. Like our last regional, I think we finished the match with all of them working about half the time. I think it's about what it was. And like a lot of it's on us, but a lot of it is like, if you forget to Loctite that one bolt, like it will come out. Just things like that.
Thank you.
Every single bolt. We're talking about upgrading to red on a lot of the Loctites too, just because like ones we Loctited backed out too. I mean, that's not good.
Sam, you are 100% right. The first time we put our modules together for practice driving, and I had one of the basketball kicking, Mr. Miller, is this one of yours? Yeah, both of our modules are all over the basketball court. And so then we just decided to go with a blue Loctite on anything that was, going to be on that module and once we did that, that solved a lot of our problems. But yeah, thanks for bringing that up. That was it was a kicker.
Well, I mean, I think we need to Loctite everything on every sword module, right?
And to be fair, Rev actually said that. Rev said in a documentation, but my kids had an oversight. It's just like note. You want to, and I think they said it for certain boats, not all of the other boats. And so then when we had that problem, I just told them, you know what? Blue Loctite everything. If you're red Loctite, I'm coming after you.
I think it's step number 1 in the Swerve Drive Specialist instructions. Get your bottle of Loctite out and put it on every bolt.
Yeah, I mean, those things, they just rattle so much and they take so much abuse. I think that's just a general rule of thumb. I don't think it matters where you're getting your kits from.
Yeah, well, I think it was a little like the initial set of Rev instructions didn't have it. That was like a middle of last year. Like they released some videos because so many teams are having problems. And then there's a couple bolts. If you tighten them too hard, like they will break things. Like that little turn stag gear. If you crank hard, which is what you want to do, oh, that bolt came out, crank hard, and then it'll actually smash the stack. So there's just a couple little things like that.
And if you don't like
gotchas.
If you don't like type the turn mode, that those little skinny bolts, what happened is they were bend trying to I had one of them got stuck in between a gear because it got loosened. And and the other thing too is with their aluminum wheels, you might want to get, if you're getting that, you might want to also get another just a replacement too, because what happens is the tread, when you put the tread on, there's not much room. I mean, it's almost like they flushed, so when you start driving that long enough, you start to see wear and tear on the edge of your aluminum wheels too. And that's something we noticed that too. So I mean, we're gonna use the same one come NMRC, NMRC tournaments, but for next year I just got new ones just so we don't want to have to risk, I mean, it's not the most expensive part of the module, so I figure it's $20 should not cost us, a tournament if we can do it.
It's interesting, Jeremiah, that you said you had damage to your aluminum wheels too, because at MRI, we noticed our aluminum billet wheels had pieces missing out of the side, and there's actually like a sliver. And we went to the field and we talked to the people on the field, and we think it's those big metal plates that were holding the stage, because those were sticking up further than they should have because those plates are kind of bent. And so we think hitting those is probably what did the damage to the aluminum wheels.
Anybody else have any sort of open topic stuff before we kind of shift gears and talk about prototyping? Okay. Well, if anything comes up, feel free to hop in. This was a night where no one signed up for a topic, so it's kind of a bring your own topic night. What the heck am I trying to say? I'm potluck. There you go, potluck. That was the word I was looking for. Topic potluck. All right. So anyway, one of the things that I'm curious to know about, if any teams have pre-built prototyping rigs for intakes or for shooters. Did you find blocks on Thingiverse that you 3D printed that were quick mount motor mounts? I know that came up once last year. I think Ian from Emperors brought up and even showed the blocks that he had, quick mount blocks that he had made for their team. I know they didn't hold up very well in competition. He showed them being broken. But for prototyping, I think we all agreed they were really good. I have a link to those somewhere. I could go dig them up, but I'm really curious if there are any tips or tricks that teams are using to get to prototype quicker. Okay, so nobody has any tips or tricks. So let's shift gears. If a team was to design a set of quick prototyping things, what would be the most useful for your team? What would help you get to the answers you're looking for the quickest if it was easier to do what?
I'm not sure if I got your questions. Are you saying what would
all right,
be,
so let me give you my example. So
yeah.
I feel like our team spends too much time prototyping intakes. And I feel like it would be really nice if we could have something that's just on a dolly. Doesn't even have to be on a robot chassis, but something on a dolly that has a variable height and distance shaft that you could move it in a quarter of an inch or half an inch at a time to find the right height off the floor or the right distance forward to go like up over the bumper type of intake. And so purely static, right? We're just trying to find what is the dimension in the down position to be able to pick up our game element. And so I've been considering trying to figure out how do we design a rig so that we can mount a motor with a fixed length belt and the entire mechanism sort of slides in and out and up and down, and you can tighten it up with wing nuts or just maybe the regular nuts and bolts and get out a ratchet or something to move it and tighten it down and then test. That's not something that would take longer to build than what it would take to make a prototype in the season. And so we don't do that. We don't build this variable dynamic type of thing because trying to design and build that thing would take way longer than trying to just build the rig you're trying to do. But if you were to do it ahead of time, like in the fall, before kickoff, maybe that becomes a much more feasible solution.
So Scott, I have to ask, just from my work before robotics, are you talking about something other than simply applying 80-20 to solve the problem?
Well, do you think that that's the right solution, is to use 80-20 and mount intakes on that? I know that, so Ben posted in the chat, I haven't followed this link yet, but I suspect I know exactly what it is he's talking about. And I think that does mount on 80-20. Yep, that's that just goes on 1x1 aluminum.
No, it doesn't mount to 80-20. We actually had to modify them to mount to 80-20. I can go and dig through our Onshape and see if I can find them.
But Tom, so tell us about how you're doing it. Are you mounting directly to 80-20 when you're doing your prototyping?
Well, I'm in the theory side of the discussion here now, right? So that is what I would advise students to do were they willing to listen. Just because it's readily available, it's not cheap, but it gives you infinite flexibility as long as you've designed it correctly. And it seems to me it solves the problem that you're posing.
As long as you have the mounting blocks, right? I mean, I think that's what it comes down to, is you still have to have either bought or designed or 3D printed or all of the above the mounting blocks, because you still have to drive. We had always done our intakes with drills. And so you put your drill on the intake and you turn the drill on and you see what it does to intake in. And that works okay for intakes. It doesn't work really great for shooters, because when you want to like test different velocities, now you really need to have a motor controller. And for almost all the motors you're doing now, they're all brushless. So you can't just use a potentiometer on a brush motor, with an old school PWM motor controller. Now you got to have a rover reel there. Now you got to have CAN so that you can do the feed forward and all of that other business to rev up your shooter and get to velocity and hold it. So I don't know. I feel like the prototyping is by necessity becoming harder to do because of the motor setups you need to do instead of just using a drill. Again, I think you can still use drills for intakes because you're probably going to run your intake at 100% or whatever speed. You're not doing the variability in your intakes, but I think that when you're getting into like prototyping shooters, now I feel like our prototype setups are almost so complicated they're pretty much the real thing. Go ahead, Eric.
Yeah, well, we're using motors with the sparks, and then we can use just tools on the computer to run that motor whatever we want. So that's I mean, obviously if you're really down in the dirt, you can use a drill, but we'll hook up a motor and then set up the RPM we want. So that's the tools we've been using for testing.
And to be clear here, you're hooking up a USB-C device directly to the Spark,
Yes.
and you're using the Rev. I forget what the Rev client is called, but you're
Yeah,
using the Rev tool.
I'm
to
sure
run
I
it.
forgot what is on the PC,
Okay.
but we just talk to one can hook directly to it, and then we can run that motor however we want, and that's how we do our prototyping.
I forgot about that. That's a good point. Yep. That's a good way to do it. And then the CTRE has Lifeboat or whatever it was called nowadays, right? And so you can do the same thing with CTRE.
Probably, yes. But as I said, we can just go right there and talk to it instead of, I mean, we have there's a tool there, just set your speed and change speed or whatever, and you can do a lot more controlled than, as I say, using a drill, and we can figure out what RPMs we want to use and such that way.
That's a good point. Go ahead, Jeremiah.
So maybe you guys address this. Is it possible to have, let's say, a pegboard where you have a motor controller, the whole 9 yard kind of like wake up system, and then whatever you need to test out, run a longer wire into that motor that's attached to your so you can kind of like, because most of that you're trying to see a motor speed, so you can run a line of code that just kind of tell you what variable speed you can shoot that ball at, or that game piece at. Just I like the drill system for Intech. It's a quick, easy thing, but like you were saying, when it comes to shooters and things, you don't really get a good feel, and then you build something and it doesn't really work out. We've had that problem before where we built something that we thought it was going to really work out and it never worked out. So then we had to modify it and settle for lesser value, but it's better to gain something than nothing. And at that point in the season, and so that's kind of, is it something that can be done?
I said if we can talk directly to the controller, to the Spark, we don't need a controller at all in the system. We just have a PC directly. I don't know, is that USB or what, to the CAN device, and go directly to the motor. We don't need any other hardware.
By the way, I'm realizing that for the YouTube crowd that's going to watch us on replay. So Ben Johnson posted the 2 links to printables. One of them was for Spectrum 3847 FRC prototyping blocks, and those mount on 1x1 aluminum. And then he also linked to 3171 Hurricane's Huralink, which is it looks like it's a cap for a Neo that basically lets you mount the Spark right on top of the Neo to make it sort of an all-in-one, similar to how you would have for a Falcon or a Kraken, where it's all in one unit. Which the question I brought up with this cap that goes on the Neo is this going to overheat the motor? But for prototyping, I think it's a really nice all-in-one type encapsulated solution. And it may end up being something you could actually put on your competition bot too. I just don't know about putting a cap on your motor. Neos aren't exactly vented, so maybe it's not a problem. When you guys are building your prototyping rigs, are you using plywood? Are you drilling holes in your plywood? Are you using a laser with thin plywood? Are you using a CNC? Are you doing it directly into aluminum polycarb? What kind of prototyping are you doing when you're trying to figure out the right dimensions and size for your mechanisms.
I would say at least here on 2847, we CNC or laser and thin plywood's kind of been what we've settled on. We've done it all. We've done aluminum. We've done we've done polycarb. It's kind of expensive for what you find out. Generally, it doesn't necessarily need it. You're not going to beat it up the normal way. And we've done some prototypes where you kind of take some 2x4s and piece something together and maybe spin it, and it kind of works. And it's just kind of, I think we've honestly been moving further and further away from that, of more like, we kind of have an idea what's going to work, and we really want like a model first, if that makes sense, before we start like making things. And even like trying to model something where we can tweak a couple like key dimensions, right? So it's like, we know we want 2 rollers on a thing, but we don't know how much compression to put on the ball. Okay, well, let's put little bolt holes so we can vary that and try, 6 or 7 different ones. And I guess I've thought of what you're talking about before, Scott, about like trying to get something like ahead of time, but it's always hard to know which there's so many, it's 3 dimensions, so anything can move any which way, and it's kind of challenging, I guess. I'll put a link in chat, and I saw, let's see if I can find it. I just remembered, I want to say it was the 4481 Rembrandts when they were testing like their 2022 intakes. And that's what they did, something kind of similar. They had plywood with a bunch of different holes in it, but I wouldn't call it universal. I would say it was very much like something they knew was going to intake a cargo ball.
Sure. I think one of the things that I think has helped us out a lot, that I think we'll probably end up taking advantage of this year, is we have a senior, Isaac. He's our CNC and CAD person, and he has spent so much time fine-tuning our feeds and speeds for our CNC that he can cut out aluminum super quick. And so I feel like we always end up buying our flat aluminum out of the scrap bin at whatever Core-Mark is called now. And so we end up buying all by the pound flat aluminum. And so since we can get things out of aluminum so quick, if it looks good in the CAD, I think we may end up doing fewer iterations through prototype, and we might actually try it in aluminum. Polycarb's a little bit different story. We actually have a lot of polycarb that we've scavenged from old field elements at the end of in Mini. But polycarb is just hard to it's not, you can't just go to a scrap place and get polycarb by the pound, so it's a little bit more of a scarce resource. We have laser cut 1/8-inch plywood and sandwiched up 2 pieces. We've done a fair bit of CNCing of 1/2-inch plywood. So it'll be interesting to see now with Isaac having so much more experience on our CNC, how quicker we'll be able to again say it looks good in the CAD, let's try it for real, and cut stuff out on the CNC rather than, like you said, screwing 2 things together in a 2x4. If it's not square, if it wobbles, it doesn't really give you good representation like it would if you had cut out the parts out of your CAD.
And I think, and I'd be curious what other people, or how they're thinking about it. I think we've struggled knowing what to even prototype anymore with the opening up of all these open builds. Like, we did a shooter prototype, and it was kind of like we didn't learn anything. We just learned what was publicly available on Chief Delphi, that 4-inch wheels spinning really fast with this much compression shoots them. And it's kind of like, I could have read a Chief thread, pulled those dimensions, and why did we build this thing? All the videos out there. So we're kind of struggling, like, what's the, what should we do? What should we outsource? Time's limited, resources are limited. Should we spend money and time on that? I guess curious how other people are thinking about that.
I don't know if you were first, Jeremiah. I'll just jump in though. How do you the open build threads seem like a kind of a black hole for time to me. How do you sort of prioritize them? Does that make sense when I ask that?
Yeah, it's good. It's a good question. I mean, maybe that's, if you can divide your team out and kind of look at all, I agree. One person going through all of them is going to be pretty nasty, but I think honestly, we've just had enough fired up kids and between kids and mentors that things tend to catch it all kind of, but it's, I don't know. And you can also follow specific threads on Chief. So like the Rembrandts one is a really good one. I don't know, basically like there's some of the Team 95 is always a good one. There's a couple other really good ones too. That doesn't totally answer the question, but yeah, do your best. I don't know. And the other thing for us is like, I don't know if other teams are fine, but like shop time is really precious. And so it's like, if you're doing things to make your shop time more useful at home or at, whatever in between, we found that really useful. So like, more time, your time there is building something that's like, you can only do there and your research can be done, not sitting there, if that makes sense.
So going with, I think Sam said it. I haven't seen the payoff of, only one time we actually did have an original idea that I have my build captain. He's the kid who's like always asking, Miller, can I try this? And I'm like, have at it. I'd rather have you ask me, can I try this? And say, what can I do? Because that's not what I want to hear. But can you guys lower that a little bit, please? Sorry. So the thing we've done, and I'm kind of inclined to push more this coming season, is there are specific teams that I've been following that thread over the couple years that we've been around to produce good, prototypes and good things, and I was just kind of want to say, hey, you look at that team, look at that team, look at that team. Tell me what's good about that. Evaluate what they're doing and what is that a good model, and what do you think that sucks if we went down the rabbit trail, And part of that I think is seen more beneficial because, like you said, a lot of these are, especially the robot in 3 days, pumping a lot of these things out there in the early state of the build season, and sometimes it's just, if your kids don't have original idea, instead of wasting material, sometimes it's just like, hey, follow all these robots in 3 days and see which ones, do you think is something that's down our alley that we can actually test out and put it on a robot. If not, then then we have to mix and match or create our own. And there was a season where we kind of built a Frankenstein robot ideas from like 3 different teams, and they all worked together, and it did well. That was this crescendo. Yeah, we kind of did that with like 3 different same mechanism, but 3 different approaches, and then we just had take that part, take that part, take that part. Let's put it together and see, and the pan out for us in our second competitions in cloud. Our first competition, a GNR, was just more like a practice run for us, and we got creamed and we broke everything because we never had a chance to. Given if we had driven our robot at home and fixed out all those bugs, I think the outcome would have been different. But we never had that chance based on the lack of resources at our school for the kids to drive the robot, and that's something. So, yeah, and the wood thing, I'm a big proponent of plywood and 2x4s for certain things, but to put a bearing in a 2x4 or the plywood, it doesn't sometimes hold very well to do what you wanted to do. And so we have a whole scrap of a 2x1 aluminum in our shop for that reason. Like, hey, put one more holes in that for another bearing hole, just because that's the material you will end up using. So if you have a scrap piece of metal that was like, yeah, why I wouldn't throw them away, we'll just keep them because it will come in handy the following season.
This is Eric. Does anybody use, I think it's called masonry board on a CNC? Because I think that was, I'm not sure if we used it this year, but previous years for prototyping, it was very inexpensive, and the CNC seemed to work pretty well on cutting holes for bearings and stuff in it. So that might be
Yep.
an alternative at a very low cost.
Yeah, we've had good luck with it. It's not super load bearing. Like we had a shooter kind of implode on us, and it just wasn't. We should have double layered it for sure. I mean, the stuff's
Well,
kind of thin too, but it cuts nice and it cuts fast. I mean,
And yeah, I mean, it's just for prototyping, distances and trying something out that isn't going to last more than a few shots, kind of thing. But
Yep.
it is something that we have done in the past.
it cuts fast on a laser too. Really
Yeah,
nice too.
I was just gonna say a laser is a better option if you have available to it. If you're doing it on a CNC, make sure you get a really good vacuum on it, because that dust is awful. It gets everywhere, and you definitely don't want that kind of dust inside your motors. Super fine particulate out of that masonite board.
Yeah.
But yeah, like you said, cheap, easy to work with, not structurally very strong, but good for its purposes.
One of the things that we learned last season for prototyping, and I'm pushing this really hard on my kids. Matter of fact, I started a wager among them because I was like, we need to invest into CAD. We need to invest into CAD. And so I just bought us 2 3D printers and a CNC router. And I told them, I was like, this is how much, CAD is important. And so I started a little wager among them from now to, it was like 2 weeks ago, till December. Whoever can design, Swerve modules with this specifications and all these components in it, and show me, you get a $15 gift card. The second place, you get a $10 gift card. Third place, you get a $5 gift card. I know we don't have money, but guess what? I've already gotten more results than I've had. So now I know that sounds unorthodox, but I'm like, I just needed to see from my kids that, and the kid who's been around, who's shown interest in CAD for the longest time, has not produced anything. He was the first to get done with designing this. And then I told him, I said, you know what? Get rid of that document, go back and redo it again, and just do that like 5 times without, so you can build that muscle memory. And he's like pumping it out. And so now going into this week, I will ask him to put a mechanism on that, on that robot to be able to, how can you put an intake on that to pick something off the ground over the bumper intake? Because with Swerve, you can't really do a split bumper now. So, can you? Maybe you can, but I haven't seen one yet. That's a good question. That's you, Scott. Can you do a split bumper with Swerve? But to answer the question, going back to the original question, is like, I think investing in the CAD is another way to save material and time too when you're prototyping. If your geometry is right, for the most part, probably, if you can prototype something from that CAD, it will most likely be fruitful. And we found that out this going season, and so that's kind of why, because we built a practice robot this past season, and it was a very not cost-effective method for it. We are not going back down that road ever again, because it was just too much money and too many parts. It's like, yeah. But when we got into the CAD, that really panned out very well for us last season, and we might want to explore that more.
Yeah, Jeremiah, we think CAD is pretty important at KnightKrawler too. This year, what we did is we had some extra money left over, and we decided to pick up 4 of the bamboo A1s because they're about $200 a piece. And so what we're planning on doing is when the kids get to a certain point in CAD, letting them check the printers out and bring them home and use them as kind of an incentive to, continue their work with CAD. It's like CAD these past few years has been really, really important, and we haven't had a lot of uptake in students that actually want to to get to the point where they can start designing parts for the robot.
Yeah, I was going to tag onto there too. Like this last year, we spent way too much time like trying to make the trap work without doing like all of our due diligence in CAD first. And I think there was some hand waving, like, oh, it's going to be close, and then to build everything and then be 4 inches short. Shoot, how do we get 4 inches out of it? Do it again. Now we're 2 inches short. Shoot, and it's just like, so some of the prototyping can probably be skipped if it, is it sound like, in theory, is it sound in the vacuum before you try to build it in real life? I think something we learned and are going to try to at least carry forward of like, if we don't have time to like design it, we definitely don't have time to like build it and fail 4 times. So that's, I don't know, takeaway for us anyway.
So an overlength adjustable prototype would have addressed the build it to the wrong dimension, right?
Potentially, trap was hard because it's like you've got a climber and you've got this arm, for us at least. So there's like 3 moving parts and there's codependencies, and it would have, though. You're right, and it's something that it's easier to grab a line and drag it and make it bigger in CAD than it is to even make it adjustable in real life, if that makes sense.
And sorry, I'm not trying to be critical.
Yeah, no, I get you. No, you're good. Yeah.
It's a point that I try to make with the students that I have, and when I have the opportunity. I can remember a couple years ago, I don't remember the exact thing they were trying to do, but they measured it. It was going to be perfect, and it didn't work. They measured it, and it was going to be perfect, and they didn't work. And then I talked to them about screen doors and turnbuckles. I don't remember if they actually used one, but the point was that you can adjust it and force it to stay where you want it to be if you use a turnbuckle, for what it's worth.
I guess another thing we've been trying with build season now going forward is like, or at least talking about, is like front loading the things we know we need to prototype. And so take last year with the notes, it was like, to make it move through a conveyor, how much compression do you want on it? How do you squeeze it to get it to go through? And just really trying to front load like the dimensions that we knew we'd need to actually prototype for, if that makes sense. Like trying to figure those out early and get those prototypes done as fast as possible. Sometimes it can be easy to like build a whole thing and just to realize really you only cared about the compression dimension, or you really only cared about that, you name it, the speed of the flywheel or things like that.
You bring up a really good point, Sam, that I want to pile on top of. So one of the things that KnightKrawler started doing a couple of years ago is, and part of this was mini trials, right? Mini trials came out, and we always wanted to go through the full design concept. No idea is a dumb idea. All ideas are worth considering and drawing up and prototyping, or cardboard or whiteboard or whatever. And then mini trials came about, and we let's take all of that stuff that we spend a lot of time on in our 6-week build season and put that into mini trials. And so all that exploration of no idea is a dumb idea, that happens during mini trials, so we can see that entire design experience of ideate, brainstorm, put it on paper, build it out of not structural material, then build it out of real material if you've proven it out, and iterate. And what that allows us to do is to give the students that full design experience, but do it in the fall. And then when it comes to the build season, then we put more guardrails up. So we pick up things with wheels. We know we're going to do Swerve. We're not even talking about a different drivetrain. We know that if we're going to shoot, we're going to shoot with wheels, and it's either going to be one set of wheels or 2 sets of wheels, probably going to be vertical, probably not horizontal. And so we put more guardrails on there based on sort of our veterans on the team. Our captains can say, this is the way we've always done it. It's always worked. Let's start there. And until we prove that doesn't work, this is the path we're going to take. And so what we try to do is we try to limit the number of things that we prototype, so that we're not prototyping 4 different shooters. We're prototyping 2 options. We're not prototyping 3 different intakes. Hopefully we're only prototyping 1 type of intake. and proving whether either it works or that's not going to be an option. What's our fallback? And to your point, Sam, of reducing the amount of stuff that you're trying to prototype, so that you get more time to work on the real robot. And my big thing is you hand it off to programmers as early as possible.
Is anybody here like, we do a very similar thing, Scott, of like trying to put some guardrails on things we know, or like saying we've done this before. There's an old, go look at the 2022 bot. Is there any reason we shouldn't do that again? You know, but does anybody else here do it differently and have like, you know, success or feel good about it? Any other opinions on it? It's always kind of a guess and check thing. So,
and I think, you know, I think part of this evolution too of we don't do things the way we used to is there's a lot of reasons why that happens. I mean, part of it is just the maturity of an organization with the process and the structure you have. But I think a big thing that's really become more and more true since 2018, 2019 is that autonomous wins matches, right? You come out of autonomous with a lead, that's huge, huge advantage. And our team has really started to adopt that of that we need our programmers to have the robot as much as possible. A mediocre robot with an awesome autonomous and awesome shooting, you know, vision shooting, is going to probably be as good or better as a mechanically awesome robot that the programmers didn't have enough time to program great autos or to get fine tuning of their shooting. And so I think that our team has really sort of adopted this idea of that software wins matches. We got to make sure our programmers have as much time as possible with the robot. And so in the old days, you know, programmers got the robot whenever they got the robot. And we tried to give it to them with at least 3 days before week 0. And I think we've done a better job of getting it to the programmers sooner. And I think that's part of that philosophy or the ethos of we design for autonomous. We make sure we have enough time for autonomous programming because we want to make sure our programmers can maximize those first 15 seconds of scoring.
Yeah, I like what you're saying, Scott, and I like what you've said, Sam. I would say that the adults that are mentoring our team are doing a lot less in terms of guardrails. We're letting them make those decisions, and they're saying more and more over the past couple of years a lot of what I've been hearing from you guys, but the adults aren't really putting that structure on them. So whether it'll take and hold over the coming years, it'll be kind of fun to watch.
I think, you know, and I want to be careful about this because I don't want to make it seem like the mentors are pushing these things. We have these conversations frequently with our captains, and our captains agree and they buy into that. And then we help them hold the schedule. I would say, you know, the students set the schedule, they put up the schedule and they write down, this is our handoff date. This is the date we're going to have this mechanism on the robot. And this is the date we're going to have this mechanism catted. And then we help the captains hold everyone else to those schedules. So I think the big part though is we just talk about it a lot. We talk about it with the students a lot. And I think that's what makes the difference is that we talk about what wins competitions and the importance of being able to optimize our code. And I think it's really shown. I think our students believe it because they've seen it. And that's the big thing is that we've had really good success with our autos the last couple of years. We've learned some really important things about autonomous, like don't make your robot turn around 4 times an auto. That's a bad idea. And our students have seen that and they've watched that and they're like, yeah, we need to not do that again. We need to be paying attention to not what's the easiest for teleop, but maybe we need to optimize for auto. So those are discussions that we have a lot. We do a lot of retrospective type of conversations like that. And because we talk about it, our students are sort of adopting that into their process.
Yeah, no, that's a fair point. And you've got a lot stronger recent infrastructure history. Sam's team, I'm not too too sure on. Yours I'm quite familiar with, or sort of familiar with. So yeah, hopefully we can kind of build up to that same place where it's this shared conversation. So sorry, I didn't mean to assume the wrong thing there.
No, and I, what you said about, our history, use our history, talk to your students about, did you go listen to the roundtable and hear what other teams are saying, because, you can learn from other teams. We certainly have learned a ton from these talks that we've had in the roundtables, from everything you guys have been sharing. So, find ways to have those conversations. And if you don't have the history in your own team, look into other teams, because, that might be a way.
Yeah, and ultimately, Tom, too, it's about figuring out what your team wants to do, and so once the team leaders, if your student leads kind of buy into that, we've got some mentors here, we've got some history, a lot of it is asking us, what have you seen worked well in the past? So actually 2018, they said we're kind of stuck on this, what worked well. It's like, well, actually 2018, here's a video, and kind of giving them like those right leads, and saying, hey, I know in 2023 we made a robot that like didn't have a rolling grabber at clamps, and asking us how'd that go. This is both our student leads who were there when they were underclassmen, and the adults who have been there since, and giving that feedback, like, yeah, that wasn't good. we didn't like that, and things like that. It's a balancing act, figuring out for your team, whether you let the current set of kids fall into the same pitfalls you've seen before and have them learn from it, or do you put guardrails on that? It varies. I don't know. I don't know if there's a right answer, but it varies from team to team. So.
Yeah, and I think every team has a very different philosophy. I mean, I know that Talon was just on here last week and talking about how the team is very student led, and a lot of times the mentors are just kind of a stand back, and everybody has their approach, and there isn't a right way. But if you find a way that works for your team,
Talon, now we have a very strong-minded student team that really is not looking for much input from the mentors. We've had some previous generations that were more accepting of mentor input, but right now they really want to be doing this themselves. And sometimes you can try and point out that certain things are not going to work, but often they have to find that they failed the first tournament so they make those changes. So it's usually they finally agree with you to make the change for the second tournament, but that's just the nature of what our team looks like now.
Yeah, and I don't think that's that uncommon, honestly. I think teams go through those cycles. I know that I've shared in the roundtables before that we were in the opposite situation where our student leaders came to the mentors last year and said, you guys need to do more. We're overwhelmed. I think it's fantastic when students can advocate for themselves and say, this is what we need, or this is what we want. And, you figure out a way to make it work. Well, is there anything else we want to chat about? We could wrap up a little bit early here. I mean, 8:20 is not exactly that early, but I don't have a problem wrapping up early. Does anyone have any final things they want to?
There was one other thing that we
ahead.
had was the interaction between our programmers and our designers.
Oh.
And that actually was not the best last year.
And so what type of conflict did you have? I mean, what was I used the word conflict. I made a bad assumption here. What was the challenge?
Well, the programmers were asking for a design that would be easier for them to program, and the designers decide we want to make the easiest thing for us to build. And it ended up that the programming had to be extremely complex, thus Rust, in order to make a less than optimum mechanical robot work very well. So that was, I'm hoping we have a better communication this year, and our designers are willing to work a little bit better with our programmers. So that was something specific about last year. And thankfully, we did have a powerful enough language to overcome some of the mechanical deficiencies. So anyway, I'm sure each team their teams have to work in certain ways together and make certain compromises. So that's more what I'm bringing up here.
Yeah, I'm curious. I would love to get a follow-up on how that works this year. I mean, my opinion there is the design team doesn't design for mechanical, they design for robot operation. And so, that involves code. I saw a post on Chief Delphi that made me chuckle last year, and I shared it with my other mentors, that someone had posted on Chief Delphi that they decided that the easiest design, they were going for simplistic design, and so they were going to build an arm with 3 actuating joints. And I'm like, yeah, that makes sense, because it's the exact same thing 3 times for a build student, but ask a programmer how to take a 3 pivot arm and move it to a specific height in a certain way, and it's a very hard thing to do. So I made the comment that this was made by a build student, because a programmer would never say this is the simplest design to accomplish the task. Yeah, I'm curious. I look forward to chatting with you at competition, Eric, and see if things have gone differently this year based on that comment. Jeremiah, you had your hand up. Go ahead.
So I was asking about if anyone has an opinion about how you call it, split bumper, swerve, base frame. I mean, if you really, you can probably do it if you wanted to, but is it a good idea?
When you say split bumper, you're talking about like front half, back half, 2-piece bumper?
Like for an intake, so in the front where, with the good old ending mark, get apart, you can just cut that bumper, and then, have the game, robot drive with the game piece, you just come right in between, pick it up, and, but you could.
Oh, so you're talking about a frame cutout, not necessarily a bumper, but a frame cutout.
Yeah. I mean, I think mechanically it can be done, but is it the best thing? I don't know if in terms of impact resistance and strength, I don't know if that's a smart thing.
Given how much damage robots took last year with full bumpers all the way around the robot, I don't know that I would sacrifice anything, frame integrity at all. I mean, it just depends on what the game is this year. It's really hard to say.
I mean, I asked the question knowing my answer to it, but I also just wanted to get other people's feedback in the room.
Well, last year, weren't the bumper rules that you could not have a gap more than a half an inch?
Yeah.
So you couldn't have an opening in your frame to allow the game piece to go through.
Yeah, that wasn't an option last year. And who knows if it'll be an option this year, but with Swerve, man, I don't know. I don't know that I would do a bumper cutout with Swerve, especially the robots are just so fast and the impacts are so hard nowadays. I feel like an over the bumper intake may be a permanent fixture for. It just depends. Again, it just depends on what the game is.
Yeah, we did it in 2023 on ours, and a lot of 1/4-inch aluminum. I mean, we really beefed it up, and it still it tweaked. It was not good. I mean, I don't know if we do it again. It made our mechanical design so much simpler, but because the hard part is if you do the frame opening, your frame has to deal with it. But if you do over the bumper, your intake has to take it, and so it's kind of you're trading one hard design for another, but it's probably easy to argue that your frame shouldn't bend. So maybe that's the one you should protect more than your intake. I don't know. It can be done, Jeremiah, if the rules allow it. And if you want, I can give you more. You can watch videos of 2047 out there, but I can show you like what the model looks like. But I don't know, 50-50 on it. Didn't love it.
Thanks.
All right. So you guys said over the bumper. I don't study this enough. Was under the bumper really that bad compared to over the bumper?
Oh no, I mean we did under the bumper last year too. I'm just saying, like in general, if I had to have a frame cutout or go over the frame over the bumper, I think I would choose to go over the bumper. It'll be. I mean, we've never had a year in the past where under the bumper was even an option because the game piece it just would have never worked. So this was the first time under the bumper was an option. I'm glad we did under the bumper, and I think the teams that did under bumper probably preferred that too. But yeah, I just meant in general.
I was gonna say, going back to Eric, your point about, with robot design and mechanical and software, I don't know if we've got it figured out either, but when we decide on the robot architecture, it is everybody's in the room talking about how hard is this mechanically versus software, and what do we have for resources? If it happens to be a year where you've got 8 whiz program kids and not a lot of mechanical design, maybe really getting actually everyone to agree and buy in on that final architecture and agree, yes, we can achieve this software. Yes, we can achieve this mechanically. Yes, we have the tools to build this. And at least that way they've agreed to it, even if, and being honest about your resources is always too, of saying, and maybe a double jointed arm, we don't have the software for that this year, or we can't do 8 custom gearboxes this year, whatever it may be. It's not a catch-all solution, but at least facilitating that conversation among your student leads might help a little bit. I don't know, just a thought.
This might be a little late for me to throw this out there, so you can do with it what you will, Scott. But I'm kind of curious, in the real world, not everybody involved in an organization does design, and I kind of wonder if that's a weakness or strength. Do all the teams actually have everybody involved? We kind of struggle with it. I think our prototyping went on, or our how do I say it? It took us a long time to fix on a design this past year, and it kind of concerns me a little.
I can share that on KnightKrawler design team it used to be open to any returning students because they had to have been through a full season. Now that we have mini trials and students get that sort of experience in the fall, we do let new students be on the design team. But design team meetings happen off cycle, so they're optional meetings. And so it requires extra commitment. But we have both programmers and build students. I can't remember the last time if we've had a media student on the design team, a student who did photography or video production that was really engaged in what the robot, how it performed. But we always have programmers and build students on the design team that makes the decision of what's going to get prototyped and what prototypes work the best to become final mechanisms. It's not a whole team decision, though. We have the whole team work on their prototypes, but the decision about what gets prototyped and then what gets on the final robot is decided by the design team. And it requires extra commitment to be on the design team.
3926, the Emperors, we have like everyone in a room, and there's people from all, like everyone from all different sub teams, and we just have people bring their designs up onto a board, and we critique each design, and we pick out a couple designs that everyone kind of agrees that is the best in a way, and eventually we just come down to 1 or 2 designs, and they tend to work really well. So I don't know.
I was going to say, for us, we try to have architecture done by the end of week 1. That's kind of our goal. And if it's not, I don't know, it kind of has to be, if that makes sense. It doesn't have, and we can switch if there's a consensus among the leads that like we're on the wrong path, we're allowed to pivot, but really try to, and I think even just having that deadline puts a sense of urgency on it. He doesn't lets you commit more. But it's really hard.
Okay, we have run to 8:30. Any final thoughts here before we wrap it up? Okay, so coming up, we've got the 27th, I guess. That's 7 days from the 20th. So October 27th, and then November 3rd, I think it might be, or the 4th. I will not be here on the 3rd, so I will have to get somebody else to record the session, but I would love it if somebody would actually sign up for a session so that I didn't have to come up with something on the fly next week, and certainly on that first week in November, because I will be out of town. So if you're willing to, please consider signing up to host a conversation. It'd be great if a team was willing to do another get to know our team like we had No Mythic do a couple of weeks ago. So if you're interested, please do that. You can go to team2052.com/roundtable. And that's where you can join the mailing list. There's a link there to sign up to host a topic. I also send out the host a topic link in every weekly email that goes out. So here's my weekly call. Please sign up to host a topic or give a presentation. And if you have a student or a mentor who's giving a talk at Jumpstart, this is a great place to practice. Come and give your presentation on here. So that you get a little practice before you do your Jumpstart presentation. All right. Thank you, everybody. It was a good chat. I look forward to seeing you all next week. Have a good night.